So today we're going to be working with the Pythagorean Theorem again, but we're going to be looking more at distances. If you're given 2 points, how could you find the distance between them, the lengths of sides, those sort of things. But before we get into that, our warm-up today, just going over again the Pythagorean Theorem, how can you prove that something is a right triangle? So go ahead, try these 2 problems on your own, and then we'll come back together and we'll go over the answers. So for the first one, we're going to use the Pythagorean Theorem. Oh, I've got to switch to my marker. So a squared plus b squared equals c squared. So that's going to give me 9 squared plus 12 squared, needing to equal 15 squared. So 81 plus 144 needs to equal 225. So 225 equals 225. And pretty much your answer checks. So you would say yes, the first one is a right triangle. Second one, you're going to have 3 squared plus 5 squared equaling 7 squared. So 9 plus 25 needs to give me 49. 34, well, that does not equal 49. 49. So the second one would have an answer of no. Because those 2 sides didn't match, we can't assume it's a right triangle. Actually, we've proven that it's not a right triangle. So as I mentioned a little bit ago, we're going to be looking at distances. And all the distances we're looking at today are really going to just kind of focus on the coordinate plane. That's going to allow us to count some boxes and work with things that way. So for the first one, looks like my things kind of got squished together. But the question basically comes down to what's the distance between these 2 points? Basically what we're going to try to do with all of these today is we're going to try to draw a right triangle on the coordinate grid. And then using that right triangle, figuring out what our distance is. I'm probably not going to draw straight lines while trying to write on the iPad, but I think you'll get the general idea. So I connected my 2 dots. You'll notice that that's diagonal. So this is going to be my C, or my hypotenuse side. I'm going to go from the other 2 points and get my bases of A and B. You'll notice so far we don't have any numbers. In order to get the numbers, because we're on the coordinate plane, we can use the straight sides and we can count how many boxes. We're not interested in the ordered pairs. It doesn't matter that I'm down in a negative quadrant or anything like that. All of our distances are going to be positive, so you're just counting boxes. So for instance, my height over here, if I count my boxes, I have 1, 2, 3, 4, 5. 5 boxes. So we're going to say that A has a length of 5. B, on the other hand, if we count the boxes, 1, 2, 3, 4. So my B side is going to have a length of 4. I now have my 2 lengths, one missing side, and a right triangle. So I can go ahead and use the Pythagorean Theorem. So 5 squared plus 4 squared needs to give me C squared. So 25 plus 16 needs to give me C squared. 41 needs to give me C squared. Square root each side in order to get rid of that exponent of 2. When I square root 41, we're going to get 6.4, equaling the distance between those 2 points. We weren't given any sort of measurements for labels or anything like that, so you would just go with 6.4. Same sort of idea here. Again, I'm going to connect my 2 points first. And then I'm going to draw the triangle. This one I'm going to see. I think it'll let me zoom in. Let me zoom in. There we go. I'm going to zoom in a little bit so we can see. So I'm going to connect down and across. One side has a length of 1. My other straight side has a length of 3. And again, I'm looking for that diagonal. So 1 squared plus 3 squared needs to give me c squared. So 1 squared is 1, 3 squared is 9. 1 and 9 gives me 10 equaling c squared. We're going to square root again to get rid of that exponent. And the square root of 10 is going to give me a distance of 3.2 in this case for c. I got to find out how to zoom back out. Let's go there. There we go, 3.2. I'd like you to go ahead and try these two on your own, and then we'll come back together like normal and go over the answers. So now that you've had a chance to go over them, I'm going to zoom in on each one separately to allow us to see a little more clearly instead of trying to cram everything in. So starting with the one over on the left-hand side first, I'm going to connect my dots. I'm going to draw my two straight sides, my bases, my A and my B side. Count the boxes, 1, 2, 3, 4. 4 boxes going up, 2 boxes on the bottom. Again, looking for that hypotenuse. So 4 squared plus 2 squared needs to equal x squared. So 16 plus 4 needs to equal x squared. So 20 needs to equal x squared. Square root each side to get rid of my exponent. Square root of 20, I'm getting a length of about 4.5. A nice check for you as you're doing these is to remember that the hypotenuse should always be the longest side, and it shouldn't be outrageously longer. So if we have bases of 4 and 2, a length of 4.5 seems about right. It's a little bit bigger than my other sides, but it's not out of the ordinary. So now I'm going to zoom back out on the one on the left, and we're going to zoom in on the one on the right. Again, connect your 2 points. Draw your legs or your bases, count your boxes. 1, 2, 3, 4, 5, 6, 8 on the bottom. So that gives me 2 squared plus 8 squared equaling x squared. 4 plus 64 equals x squared. 68 equals x squared. Square root, square root. Square root of 68, you're looking at about 8.2 for your x value or your hypotenuse length. As nice as it is to just have the dots and be able to create the triangle, sometimes they come in real world problems. And here what you have to kind of realize is that you need to use the Pythagorean theorem. The problems may not just straight out tell you that you need to use the Pythagorean theorem to find the distance, but giving you the graph, giving you some points, asking for you to find a distance, your first thought should always be, can I draw a right triangle? Because that's going to always be the easiest way to find the distance between 2 points, is if you can create that right triangle. So on a park map, we have a ranger station at the point 2, 3. So over 2, up 3. That right there. And we have the nature center at 0, 4. So over 0, up 4. About right there. And we want to know the distance between the two. I'm going to zoom in now so we have a little bit better view. So I'm going to connect those 2 dots and I'm going to make my triangle. Even with zooming in, it's a pretty small triangle. My bases are just 1 and 2, and I'm looking for that hypotenuse. So 1 squared plus 2 squared needs to equal x squared. 1 plus 4 needs to equal x squared. So 5 needs to equal x squared. Square root each side. Square root of 5, we're getting 2.24 or 2.2 as our x. Zooming back out, Again, it didn't give us any sort of inches, feet, miles sort of information. So you would just go with 2.2 as being the approximate distance. Same sort of thing here. This time we're looking at 412 and 62. 412 and 62 over to 6 up to 412. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, 412. Over to 4 up to 12. So about up here. Because it went off the graph, we can still solve the problem, but we're going to need to remember when we're counting that we went off the graph by 2. So there's 2. As I count my boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this distance, my height, is going to end up being 10. So 10 squared plus 2 squared needs to give me x squared. 100 plus 4 needs to give me x squared. 104 needs to give me x squared. Square root, square root. When we square root 104, we get 10.2 approximately for our x. It did round up. Rounded up to 10.2. We have 2 problems here. I'd like you to go ahead and try these 2 on your own, and then we'll come back together and look at these together. All right. So I have the 2 graphs. Again, I'm going to zoom in. The first problem, the coordinates that were given to us were 4, 5. So over to 4, 2, 3, up to 5. Ooh, that's a big dot. And over to -1, up 0. So I actually have quite a bit of distance this time that we're looking at. It does not matter which direction your triangle goes. Your triangle may go different in a different direction than your neighbor's triangle, but it's not going to change anything. So I'm going to make my triangle look like this time. Still got my right triangle. Counting 1, 2, 3, 4, 5 going up, and 1, 2, 3, 4, 5 going across. So 5 squared plus 5 squared needs to give me x squared. So 25 plus 25 needs to give me x squared. 50 is going to give me x squared. We're going to square root each side. And x gives us 7.1 rounded. The second problem, we were given the coordinates -2, 3, so over -2 up to 3, and 4, -1. 1, 2, 3, 4, down to -1. Again, we're connecting the dots. I have a height of 4 blocks, 1, 2, 3, 4, 5, 6, and a length of 6. So 4 squared plus 6 squared needs to give me x squared. 16 plus 36 needs to give me x squared. 52 needs to give me x squared. Square root each side. And 7.2 is going to be our distance for this one. So here, the next 2 problems we're going to look at are going to be some multi-step problems. You want to read the problem as carefully as you can, map out all the information that you're given, And then you're going to want to look and see where you can make triangles from there. And sometimes you may have to make more than one triangle and do more than one Pythagorean theorem to end up at the distance that you need. So we have two cars that are leaving. They're both leaving out of the point 0, 0. So they're both leaving out of the origin. One car is going to go 8 miles north and then 6 miles east. I'm going to zoom in for a minute so I can graph this. 8 miles north, 6 miles east. So 1, 2, 3, 4, 5, 6, 7, 8 over 6. 1, 2, 3, 4, 5, 6. Zooming back out. Our second car goes 12 miles south and 9 miles west. So our second car, 12 south, 9 west. So 12 south, 12 south, 9 west. And it wants to know how far apart are the two cars. It wants this big, long distance. Now you have some options here, depending on how you want to go about solving this. And I'll show both of them to you with the laser pointer, and then I'll show you the one that I would pick. You have the big triangle. You could actually do the big triangle and count the boxes and just make sure that you're counting correctly. You can also do, because they started at the same point, you can do each of the smaller triangles separate and then add the two Pythagorean theorems together. And that's the way I'm going to do it. And the reason is I already have these base measurements. They were given to me in the problem. So I can just use those and then kind of expand upon it from there. So for my first car that went north and east, my bases are 8 squared plus 6 squared needs to equal x squared. So 64 plus 36 needs to equal x squared. So 100 equals x squared. Square root, 100 being a perfect square. We know for the first car, its distance from home was 10 miles. We do have labels this time. So 10 miles. Our second car, we know it went 12 miles south, and then it went 9 miles west, and we're looking for its hypotenuse. So 144 plus 81 equals x squared. You get 225, which also happens to be a perfect square. We're going to square root each of those sides. And you figure out that the second car is 15 miles from the starting point. So now your total distance is going to be the 10 of the first car plus the 15 of the second car for a total distance of 25 miles. So on this one, we have a whole heck of a big, long problem. And we're going to need to piece out the information and see what we're actually looking at. My graph is on the next slide over, so we're just going to break down the information here, and then I'll show you how to put it all on the graph. So we know that the hunt begins at the point 0, -5. First clue, it says, is hidden 5 units north. So we're going to go up 5. Second clue is 6 units east of the flagpole. So you're going back to the flagpole and you're going 6 to the east. And it wants to know the distance between clue 1 and clue 2. I then know that clue 3 is located 5 units north of clue 2. And I want to now know the distance between clue 1 and clue 2. And then I want to know the distance from clue 3 to the flagpole. I'll show you how all this breaks down. It's not that bad. A lot of information, but you'll see if you look at the chart. And again, I'm going to zoom in so we can look a little clearer. So we're starting at our flagpole at 0, -5. So 0, -5. 1, 2, 3, 4, 0, -5. It says the first clue is 5 miles north. So here's clue 1. Clue 1. And we know that that distance is 5. It says that clue 2 is 6 miles to the east. So 6 miles to the east, we know that distance. And the first thing it asks us for is what's the distance between clue 1 and clue 2? What's this value? So from clue 1 to clue 2, that's going to be 5 squared plus 6 squared. So we're pretty good at the Pythagorean theorem now, so for the sake of space, I'm going to kind of shrink things up a little bit. So the 5 squared is 25, and the 6 squared is 36, and when we add those two together, we get 61. So 61 equals x squared. Square root each side. Square root of 61. And we're getting 7.8 as our x distance there, the length between clue 1 and clue 2. We're then told that clue 3 is 5 miles north of clue 2. So 5 miles. And then we're being asked, what is the distance, so this is clue 3 here, what's the distance between clue 1 and clue 3? And all you're going to do there, you don't even have to make the triangle. All you're going to do is count the boxes. And if you've noticed, we've made a rectangle. So it should match the opposite side. So since we already knew that one length was 6, we now know that our second length is 6 as well. So that's the second part of the problem. The last part of the problem says it wants to know the distance from clue 3 back over here to the flagpole. Two things you can do here. Best thing to do is to do your Pythagorean theorem again. So 5 squared plus 6 squared equals c squared. And you get 61 equaling c squared. Square root each side. And you get that distance again to be 7.8. You may have realized that it was 7.8 because we are looking at a rectangle and we're just looking at the other diagonal. And because it's a rectangle, those two diagonals are going to have to be the same length. So either way, if you're going to reason because it's a rectangle and the diagonals would need to be the same length and all of that, you need to make sure that you can actually explain it. Okay, if you're asked further on down the road, well, why do you think it's 7.8? You need to be able to talk about how the two diagonals would be equal. And that's the lesson for today. You should have a worksheet to work on in front of you. If you don't, you should be able to pull it off the homework calendar on the website. And if you have any questions, need any help, feel free to come see me.